this video, I wanted to talk about completing the square. So here's an example of completing the square. Now, at this stage of the game, you've already been taught how to solve quadratics using factoring, where we come to two parentheses and then solve for x. When we are given an equation that cannot be factored, so if we look at this and immediately think, okay, what two things get me to 3? There's only 3 and 1. Those will never add up to 6. So immediately we can see, okay, this cannot be factored. So at this stage of the game, we're given a couple of tools in our toolbox in order to solve quadratics that can't be factored. And one of them is completing the square. Soon you will be asked to use whichever tool is your preferred method. If you prefer factoring, if you prefer completing the square, and if you prefer quadratic formula. Quadratic formula always works. Factoring, you're starting to learn, only works if it can be factored. So if this is an example that cannot be factored, we might try completing the square. We could also do quadratic formula. That would always work. But completing the square is another method that can be a little bit easier than quadratic formula. So let's try completing the square. What I always say is the first step to completing the square is giving yourself a blank. Essentially what I'm doing is taking just the first two terms that have x in it, and I'm going to make them a perfect little square. So I still have this -3 over here. And we always want to set quadratics equal to 0 in order to solve. Because if we quick talk about quadratics, they are a parabola, and as a real quick review, the zeros are where we cross that x-intercept, or the x-axis. Those are the x-intercepts. And we will call them the roots, the zeros, the factors, the solutions, a lot of different names. So completing the square, we give ourselves a blank. And what goes in the blank is b over 2 squared. And if we remember, the standard form of a quadratic is ax squared plus bx plus c. So the standard is positive. So in our case, we have a -6 is our b. So if we do -6 over 2 and then square it. So -6 over 2 is -3. And if we were to square that, it becomes 9. So -3 squared is 9. So it's a +9, and that is what goes in our blank. Now it feels weird. We've just randomly, according, different from our original equation, we have randomly added a +9. So if I do it on this side, I have to also do it on this side. That would make both sides of the equation still the same as my original. So just remember, whatever goes in the blank, you have to add it to the other side. If we're finding the vertex form, which we'll talk about in a minute, we want to keep everybody on the same side. So for now, if we are solving by completing the square, we're going to add the 9 to the other side. So the next step I always feel like is a little strange because it's like we went forwards with b over 2 squared, but now I need to get back to my perfect little square. So what is this if I were to factor it, or I need it to be a perfect square? And the trick is just to use the b over 2 here. So we had -6 over 2, and that was -3. So that means in my perfect square, this is the -3. So we could also think about, okay, factoring that square that we did. So now we added our blank. If I were to just try to factor that, I'm thinking of 2 factors of 9 that add up to 6. So immediately we think, yes, that would be -3 and -3. So if I FOIL to check, that would give me the first term x squared, outer is -3x, inner is -3x, that adds up to the -6x, and my last term would be that +9. So that's where all that comes from, but the trick is, if you can remember the trick, b over 2 squared goes in the blank, and then the b over 2 is what is our perfect little square. So we could go ahead and finish that out. That takes care of that. That is our perfect square. And now on the right-hand side, we would have a positive 9. So if we want to solve, I want to move the 3 over. So that would give us, I'm going to move it up here. That would give us x minus 3 squared equals, our 9 plus 3 now would be 12. And this is what feels a little bit strange, but when I have a perfect square over here, that means to cancel out the square, I can just take the square root of both sides. So the square root of 12 isn't such a great number, but over here, that would just be, that means our square and our square root, those cancel each other out. The square root of something squared is that something. So x minus 3 now equals, and in this case, we always say plus or minus the square root of 12. So we start saying that anytime we have a square root, we have a plus and a minus. And if you remember, whenever we have a quadratic or an x squared, because of those parabolas, I need 2 solutions for x because I cross the x-axis twice. So that's the nature of the quadratics. We have 2 solutions. So for when we have a square root, we're going to do a positive and a negative. To solve for x now, I'm going to add 3 to both sides. So if I add 3 to both sides, it gets a little bit weird, but here we're going to put the 3 in the front. That would be 3 plus or minus the square root of 12. Some teachers would accept this as your final answer. Some teachers would prefer you to reduce that radical. And if you need help reducing radicals, you can check out my other video. But to reduce that square root of 12, we know that is 4 and 3. 4 is 2 and 2. So I can bring out the 2 and the 3 remains underneath. So if we change that to the square root of 12 to reduced, that would be plus or minus. We brought out the 2 and the square root of 3 remained underneath. So this would be the reduced form, and most teachers would probably accept the plus or minus. If they wanted you to write that out, you could just separate that. So x would equal 3 plus 2 square roots of 3, or 3 minus 2 square roots of 3. So that would be solving for x by completing the square. Other times, we may be asked to just keep it in vertex format. So vertex format, if you remember, when we're talking about parabolas, we have a point that is the vertex. So somewhere here would be the vertex. So, and to get that, I'm going to keep that up there and do the same example, but keep it in vertex format. So vertex format is, the standard form is x minus h squared plus k. And h comma k is our vertex. So in this case, we often use completing the square to get it in vertex format so we can immediately graph. Immediately, my vertex would be h comma k, wherever that is, h comma k. That is my vertex. So if we needed to graph and we were given this original equation, we could immediately think, well, I don't really know how to graph that, right? Given x squared minus 6x minus 3, I don't even know what the zeros are because I can't factor right away. So completing the square is a good option for this one. So again, if we quickly do what we had just previously done, this would become our x minus 3 squared, right? That was our perfect square from last time. But this time, instead of adding we had a 0 over here originally, instead of adding the 9 that was our blank to the other side, I'm going to keep the 0 and I would just keep the 9 on this side. But because my blank was, and up here I'll go ahead and put what we had done, our blank was the b over 2 squared. And for us that was negative 6 over 2, which is negative 3, and that squared would be positive 9. So you can see here, if I keep it on the same side, I don't want to add 9 because that would be like adding 18 to this left-hand side. So if I add 9 on this side and want to counteract it on this same side, I'm going to subtract 9. So you can see here in the blank, we've added 9. And then to make sure we haven't changed the value of this equation, we've just changed how it looks by completing the square and getting it in vertex form. So I'm going to subtract 9 to counteract it here because I've added 9 inside the parentheses. I'm going to subtract 9 on the outside. So to finish this up, this would be x minus 3 squared. And outside here would be minus 12. And we could still set that equal to 0. And you can see here, right, if I move the 12 over, again, we're back to where we were. X minus 3 squared equals 12, and that's just where we were. So no matter where you put it, you're going to get the same values for x if we were to solve for x. But in this format, you can see now I'm in vertex form, x minus h squared plus k. So if you remember, the standard is minus, so my h comma k is just the 3, and then the k is the sign that it is, so that would be negative 12. So my vertex, h comma k, is 3, negative 12. So if we were to quick graph that, that would be positive 3 and down negative 12. So our vertex would be down. And this is a positive parabola, meaning it's going to open up. So be something like that. We could graph some other points, plug some points in to find them if we needed to graph. But otherwise, the general shape would be something to that effect. So that would be a quick way to graph by completing the square. So that's one example. So let's do another a little bit more complicated. Here is 2x squared plus 8x minus 5 equals 0. So to complete the square, again, I'm only looking at the first two terms that have x. And immediately, whenever there's this a term, I want to try to factor him out if I can, because it's much easier to factor or complete the square without an a term. So I can see that 2 would factor out of both of those. So I'm going to go ahead and pull the 2 out, and that would give me x squared plus 4x, right? If I'm thinking about redistributing, that's what I've done essentially. I've pulled a 2 out of both of those, and then if I kind of go forwards and backwards, I can redistribute it to check. So that would be 2 times 4 would be 8x. And then I'm going to give myself the blank, and out here we still have the minus 5. So in the blank goes b over 2 squared. So for us, that would be 4 over 2. This is my b term. 4 over 2. 4 divided by 2 is 2, and we square that. So that would be 2 squared, which equals 4. So again, positive 4. So if I've added 4 onto the left side, I need to add 4 to my right side. So then inside my perfect little square goes the b over 2. Oh, and actually we have to be really careful. See, I just made that mistake. So if I've added 4, but since I took out that 2, I've actually added a total of 8 to this left side. So I have to actually add 8 to the right side. So it's so easy to mess that up, right? So we just have to be really careful and keep that 2 there if I've pulled him out. So what I've actually added to the left side is a positive 8. So to counteract that, I have to add 8 to the other side. So then back to my perfect little square, I'm going to keep the 2 on the outside. The b over 2 is what goes here. So that was my x plus 2. 2 was the b over 2. So that is what would go for my perfect squared. So x plus 2 squared. And we could double check that, right? If I go x plus 2, does that get me to this original piece here, or that piece that we completed? And it does. So that would be my outside would be 2x, inside 2x, and last term would be 4. So that's my perfect little square. I still have my minus 5, and it equals 8 on the right side. So now to solve by completing the square, I'm just going to get this parentheses chunk by itself. So I'm going to add 5 to both sides. That would give me 2 times x plus 2 squared equals 13. So this is going to end up being not a pretty number, but now I want to keep getting the parentheses by itself. So to get rid of the 2, right now it's being multiplied. So to get rid of it, I'm going to divide by 2. So I'm going to move up here. If we have x plus 2 squared, and it equals 13 halves over here. So that's not a pretty number, but we'll go ahead and keep it like that. So now to get rid of the square, I'm going to square root both sides. So that gives me the inside something. When I square root something squared, I'm left with that something. X plus 2 equals, and my rule of square roots, I can just do square root of 13 over square root of 2. Still not very pretty. Most teachers would want you to rationalize that radical, meaning I don't want to have a radical on the bottom. So I'm going to just give myself a little bit of room here. And if I rationalize that radical, I'm going to multiply both top and bottom by square root of 2. That's just multiplying by 1, so I really haven't changed the value of my equation. Okay, so what we would have next is we would have our x plus 2, and our rule of radicals here is I can multiply under the radical. So that would be 13 times 2 under the radical would be square root of 26. And then on the bottom, like we said, square root of 2 times square root of 2, that would be the square root of something squared. It gets me back to that something. So that would just be 2. So square root of 26 over 2. And then, and I always want to do plus or minus here, and we would subtract 2 then to solve for x, subtract 2 from both sides. So I typically like to put that standalone number up front. So in our case, x would equal negative 2 plus or minus square root of 26 over 2. So that would be our solutions. That would be our zeros for x. So now if we want to go back to solving using the vertex form. So if I go back to where I was here, that would be, we had our 2 on the outside and our perfect little square inside was our x plus 2 squared. And what we had done was that was our x squared to get our blank was plus 4x plus 4. So our blank here was 4, but what we actually added to this side was 8. So again, to counteract that on the same side, instead of adding 8, I'm going to subtract 8 on the outside. So that gives us minus 8 minus 5 if we're keeping it on the same side. That would mean then our vertex form is 2 on the outside, x plus 2 squared, and these two would become minus 13. So that means our h, x minus h squared, this is our standard vertex form. That means our h is actually negative 2, because if we think about that here, if I switch over here, that would be x minus negative 2 in that parentheses. That would give me x plus 2, x minus the negative. So that means h is actually negative 2. So my h comma k is actually going to be negative 2 comma negative 13. So real quick here, if I graph that parabola, that just means that my vertex is here at negative 2, negative 13. And I know that my first coefficient is positive, so that means it would be something like this. And the 2 on the outside actually makes it, so that was 2x plus 2 squared, and we had a minus 13 on the outside. So that means here with the 2 on the outside, it makes it a little bit skinnier of a parabola. And we could check those zeros. So if we check those here, if we do the square root of 26 on our calculator, that's actually 5.1. So here, and then we're going to divide by 2, divided by 2. So that's really close, 2.5. So that means here we have it like a -2 plus, if we do the plus option, 2.5. So that is pretty skinny. That means that one of these zeros is over here at positive 0.5. And then the other one that would be -2 minus 2.5. So that would be like -4.5. So that makes sense that it's more something like this. So a little bit skinnier, but we still have one of those zeros would be positive. So that's always a good idea, is if you're not sure about a square root, you can always put it in the calculator to find the decimal value so you can kind of see that magnitude on the actual graph that you need. So that's a good check there. So that would be our vertex form for that particular one. And the solutions are what we already did, or the zeros, that would be solving for x using that completing the square. So that is completing the square, solving quadratics by completing the square, and graphing using the vertex form of parabolas in order to graph them. If you have any questions, feel free to comment below and let me know how you like to use completing the square.